In this video, we are going to continue to look at exponent rules, specifically explore what happens when we have a negative exponent. So just a quick recap. These are our 5 exponent rules so far. Remember, they all have to do with when we have the same base. So when I have the same base and I'm multiplying, you can see that I'm going to add my exponents here. When I am raising a power to a power, I'm going to multiply here. When I have things in a parentheses and I'm raising all of it to a power, I'm going to distribute my power here. When I have a fraction, I am going and I'm dividing the same base. I'm going to subtract my exponents as I did here. And hopefully remember from the last video that when you raise something to the power of 0, that is the same thing as just the number 1. So we are going to look at another rule. We, in the last video, explored a little bit about what happens when we subtract and we end up with a negative exponent. But the new rule here is that when you have x to the negative a, that ends up with 1 over x to the a. So I'm going to show you what I mean by this. When we have 3 squared over 3 to the 4th, I'm going to expand it out to first explain it to you. So I end up with 3 times 3 divided by 3 times 3 times 3 times 3. Now, we can now cancel out the same from the top and the bottom. That means that on the bottom, I'm left with 3 squared. But what happens to the top? Well, in order for us to have a fraction, we always have to have a numerator. So my top, or my numerator, becomes the number 1. If we think about our rule here, my exponents are 2 and 4. So what I've done here is I've said 3 to the negative 2nd, because 2 minus 4 is negative 2. Well, based on this 6th rule, if I have 3 to the negative 2nd, it looks like this, meaning my positive power of 2 goes down to the denominator. If we do another example here, if I have x to the 13th divided by x to the 15th, I'm going to do 13 minus 5, which gets me to 8. That means here my answer is x to the 8th. If you look at this next one, I'm now doing 5 minus 13, which gets me to negative 8. So it's really important when you do the subtraction, you do the numerator's power minus the denominator's power. So here, now that I've done 5 minus 13 and I have negative 8, that means I have x to the negative 8 power, which then based on the new rule you just learned becomes 1 over x to the 8th. If we think about this problem here, what has happened if we expand it out is I end up with only 5 x's on the top and I end up with 13 x's on the bottom. There's another math teacher in our department who talks about it almost like a battle between the top and the bottom. Well, here I have more x's on the denominator in the bottom. So my x's are going to win, meaning I'm going to end up with 1 on the top and x to the 8th on the bottom. So I am first going to do each one of these, and I want you to first pause, try the first one, we'll do it. You're going to pause, try the second one, etc. So I want you to pause now, and I want you to try 5 squared divided by 5 to the 7th. All right, so if you've done that, hopefully you've done 2 minus 7, which is negative 5. So I end up with 5 to the negative 5th, which then means I always want positive exponents, no negative exponents. I end up with 1 over 5 to the 5th. So I want you to pause and we'll do the next one. So if I have x to the 5th divided by x to the 8th, I'm going to do 5 minus 8, which gives me x to the negative 3rd. So that becomes 1 over x cubed. And pause again, please, and try the last one. Okay, and if I have a to the 12th divided by a to the 5th, 12 minus 5 equals 7. So this means I'm just going to have my positive a to the 7th. I do not need to write it as a fraction. All right, so now we're getting a little more complicated. We're going to do x, y's, and z's. I want you to pause this and try it on your own, and then I'll show you the answer under the blue bubble. But just a quick reminder, I want you to think about it vertically. Do your x's, do the y's, and then do the z's. All right, So hopefully you've tried this on your own. And now if I do x to the 5th divided by x to the 7th, 5 minus 7 is going to be x to the negative 2. So I know that I'm going to leave x squared in the denominator of my fraction. Now if I do y to the 3rd divided by y squared, 3 minus 2 is 1, positive 1. So I know I'm going to have positive y to the positive 1 power on the top. Last but not least, z, there's an invisible power of 1 right here. So z to the 1st divided by z to the 4th, I subtract 1 minus 4 is negative 3. So that tells me I'm going to have z to the positive 3 on the bottom. So your answer looks like this. Okay. If I were you, I would, when you have an answer or when you have a question like this, start by drawing out your new fraction. And then as you go one thing at a time, place it accordingly in your numerator or denominator. Remember, positive exponents only. Okay, I want you to pause and try this one again, keeping in mind positive exponents only, and do one chunk at a time. All right, so I'm going to draw my fraction. We're going to start with our a's. This a has an invisible exponent of 1. So I'm going to do a to the 1st divided by a to the 7th. So 1 minus 7 is negative 6, which tells me that I should have a to the 6th in the denominator. I have b squared over b. Again, this one also has an invisible 1. So b2 minus 1 is going to be b to the positive 1 on the top. And then here, we know that c to the 3rd and c to the 3rd, that's going to actually cancel out. Because if I end up with c to the 3rd divided by c to the 3rd, that's the same as c to the 0, which we have learned is 1. And I don't need to actually write the 1. So your answer becomes this. And that's it for now. If you have any questions, please let us know. And we are going to continue to explore and practice our exponent rules.